Hi everyone. Now we are going to build a convolution neural network that can recognize objects from the CIFAR-10 image dataset using TensorFlow and Keras. Let's see step by step that how it's working. So first we need to import the library, right? So we are going to import the TensorFlow Keras modules for the building of for CNN and along with the matplotlib for our vision. So we are using import TensorFlow STF and matplotlib.keras import dataset, then import matplotlib.plyplot, then everything we are doing. Okay. So after that, after importing, we should load the dataset, right? So we load the CIFAR-10 dataset, which contains the 60,000 color images across the 10 classes like airplane, cars, birds, and more, and etc. So we are going to like extrain and white train, extest, white test is equal dataset dot load of. Then what we are going to do is we are going to normalize and encoding it. So we normalize all the pixel values by dividing them by 255 to bring them into the range from 0 to 1. So that only it helps the model to train faster and more efficiently. So we can see that extend comma white x test is equal to extend by 255.0 comma x test divided by 255.0. Then we can see that we are like we use one hot encoding that label. So instead of using a single number, each label becomes a 10 element of array, so it will be a perfect classification. So we are going to use C extrain text is equal to character details to the categorical why train compartment. So we are going to use that. After that, we are going to build and CNN. So it's the major component over here. So model is equal to model dot sequential, then model dot add of layers. So we are in this, we are going to activate the relu function. So a model dot add layers of convert to it of 64 comma 3 comma 3. Then what we are going here, we are using the max pooling 2D layer. So this is the main component over here. So then it's doing all the components from here. So then because the count 2D layers extract the image feature like edge and features, then the max pooling layer reduces the image size to make the learning fast and avoid overfitting. So after that, what we are going to do is we are going to flattening on the dense layer. What does it means? Means you drop out the layer randomly to turn off some neurons during the training and improving the generalization. So the final dense layer uses the softmax to output the properties to each of the 10 classes. So that only model dot add of layer comma flatten off, then layers dot dent of 64. Then here also we are activating the relu function, then layers or dropout of 0 comma 5, then and after that we are activating the softmax function also. After this we are going to compile the model. So compile the model, so we use the atom optimizer and the categorical cross entropy loss and the standard choice for the image classification task. And we see this here, we can clearly say that we can use the atom categorical centroscopy and the accuracy. Then what we are going to do is we are going to train the model. So we are going to train for the first 10 approaches with a batch size of 64, and the validation data helps us to track how well the model performs on the unseen data. After the training, what we are going to do is we are going to test and accurate it. So after the training, we evaluate the model on the train set and to get a final accuracy. So what we are going to do, test loss, comma test accuracy, we are going to find, and we are going to print that. After that, we are going to visualize the effect. How we are going to visualize the effect? So we are going to plot the training and the validation accuracy and loss over a post to see how our model has been improved during the training. So by that we can able to do that last. By we can see here, we more trained 10 approaches and we got the graph in which we can see the accuracy and losses. So, and that's it. And we built a convolution neural network that classify the 10 images using the TensorFlow. Thank you guys.